Hello, let's do a Sudoku puzzle. So this one is one of the puzzles created for ChattyKathy for her birthday. As the title says up here, HBDCK, which stands for Happy Birthday ChattyKathy. And this one was then created for or by Calvinball. So we have the rules up here. Normal Sudoku rules apply. The region sum lines, box borders divide blue lines into segments with equal sums. Digits in cages must not repeat and will sum to the digit in the top left cell. Clues outside the grid are sandwiches and give the sum of the digits between the 1 and the 6 in their row or column. Okay, let's get started. So, one thing I spot immediately, before we get to that, I just want to show this to you. The lines here, they are in the shapes of 413 here, which stands for April 13th, which is her birthday then. Okay, so let's see. We can't put a 6 in here because if we do and we go for the three smallest digits that remain, 1, 2 and 3, those will then add to 12 and we can only add to 11 with these two, 6 plus 5. So we now know that either of those will be a 6 for this row. Then let's see, same with this 3 actually, it goes over 4 cells in box 4, which means if we place a 6 on the line here and then go 1, 2, 3, which add to 12, then we can't get to 12 here with 6 and 5 even. So 6 again will be on this line or this column instead. Now we can't have 1, 2 here because the smallest these could add to would be 3, 1 plus 2. So we could do 3, 4, 5, 6, but because of the 6's here in column 4, we can't have a 6 in that cell actually. So that is only 3, 4, 5. So for 3 it's gonna go 1, 2. For 4 it's gonna go 1, 3. For 5 it could be 2, 3 or 1, 4. So 1 is quite likely to be here, but it's not guaranteed. What can we determine? We have a 4 here, which means it's gonna go 1. Okay, so 1 and 6 will have to be 2 cells apart, like 1, 6 maybe, but we can't have a 6 there because of these 6's. Because the thing with the 4 is we can't have 1, 3 between 1 and 6, and of course we can't have 2 and 2. So it's gonna be the 4 on its own between 1 and 6. We can't have 6 in either of these. If we do 6 there, then that will be a 1. A 6 there will make that a 1. 6 there will make that a 1. And 6 there will make that a 1. So I think, let's do this again. 6 have a 1 there. 6 has a 1 there. 6, 1 there. And then 6, 1 there. So 1 will have to go in this column, column 5 then. And then 6 is there, or 6 is going to be there or there. What can we determine? The smallest this could be is 3 because of 1, 2. And these two digits need to be equal to one another. So let's do blue, and maybe not blue. Let's do yellow. Yeah, that looks better. Let's do yellow for those. They will be equal to one another. Then these will need to add to whatever it is in the yellow. So they could go 1, 2, 1, 3 if it's a 4. 1, 4 and 2, 3 would make 5. If it's a 6, it could be 1, 5, 2, 4. What am I probably missing? if we have, so this is gonna go 1, 2, 4. Okay, so let's see, the smallest for these would be 3, 6, 10. That's the smallest. And then if we go 2, 3 plus the 9, so that's 14. So this would be 10 to 14. Can I? Okay, it doesn't seem I can tell this thing that they need to add to 10 or 14. But anyway, to get to 10, okay, they will not be 14. And they will not be 13 either. They will not be 12 either. If we do 5, 1, 2, 3, that would be 11, which is then 6 and 5 here. The other thing we could do is yellow needs to go in either of these, so let's do yellow, white, and then yellow needs to be in either of those, let's do yellow, white. Okay. If this is a 6, we need 4 or 5 there. We need, okay, we said 10 is the smallest. So 6 is definitely going to go on here, because we can't do 3, 7. Because the lowest this could be is a 10. And the only way we could get there is 6 plus 4, and then 6 plus 5 would be 11. So this is going to be 4, 5, 6, and then we definitely have a 6 there, which means that we are definitely going to have a 6 here. So these 6's now, 6 can't be yellow, I believe. I don't think 6 is yellow. If 6 was yellow, okay, let's quickly put it back and see. This could still be a 6, and then we have I'm not sure, I think. Okay. So 4, 5, 6. So it's going to go 1, 2, 3, 4, or it's going to go 1, 2, 3, 5. So this is also then a 4, 5, 6. Because the moment one, let's say 3 comes over, then we have 1, 2, 4, 5, which is then 3 plus the 9 is 12. So we are definitely having 1, 2, 3 in there, and then this is going to be 4, 5, 6, which means this one, that will be 4, 5, 6, 4, 5, 6, 4, 5, 6. So kind of a triple, but not really, because they don't share anything with one another. So then, okay, so this is then not a 1, 2 pair. This is not a 1, 2 pair for the 3. Okay. So these could be 1 plus 3 for the 4. 5 would be 1 plus 4, 2 plus 3, and 6 would be 1 plus 5, 2 plus 4. So it's literally anything but 6. I'm not gonna pencil that now. We can't have 1, 2 here. Could we have a 1 at all in here? If we have 1 there, look, 1 is not there anyway because of these ones. If 1 is there, let's say this is a 6, which would get it the largest total it could possibly be with a 1. I think it's going to be the same concept as this 456, because we can't have a 6 on here. It's 1 2 3 4 5. Now if we remove the 3 again, these will need to be 1 2 3, and then these would be 4 5 6. Okay, 1 2 3 is definitely on the line, and then we're gonna have 4 5 6 up here, which gives us the 1 2 3 there. So 1 plus 3 would be 4. 2, we can't do 2 plus 2. Okay, so then for the 5 we have 1 plus 4, 2 plus 3, which is already there, and then 3 plus 2. And then for 6 we have 1 plus 5, 2 plus 4, 3. We can't do 3 plus 3, so that is 2 3 4 5. This is 1 2 3. These are not yellow. This is not the yellow 4 5 6. That is not yellow. What could we do? With a 4 there, that would be a 6. If 4 goes there, then that is not. Let's have a think about this actually. 4, if that's a 4, the lowest that could be is a 5. That would go 9, but then we could still do 1 3. Am I missing something? 1 2 3 1 2 3 1 2 3. That digit is going to be either of those. 6 is not there, so 6 is either of these. If we do 6, 1 2 3 is 12, so let's have a think about that. Without this 6, how can we get 7? 1 2 4. 1 2 4. With a 5, how can we get 8? It's going to go 1, not 1 2 5. 1 3 4 is possible. With a 4 to get to 9, we could do let's see, 1 6 2. 4 5 6 4 5 6. If we have 1 2 and 3, all of them here, which is 6, at least one of them will go there. They are not all there. Okay, so 4, at least 4 will need to go here. So let's do 4 to 1, then we can place a 6 there. Okay, and then we can't repeat any digits in the cage, meaning this digit is not going to go there, but it could be that one or one of those. This one cannot be there, but it could be there. I don't know what am I missing? There should be something that I'm not considering. The 3 here would give us 1 2, a 4 would give us 1 3, a 5 would give us 1 4 or 2 3. they can't be both 4, 5, 6. One of them is 4, 5, 6. Okay, that would form the triple here. So this is not going to be 4 or 5. Okay, maybe that is what I've missed. Because we have 4, 5, 6, 4, 5, 6, and then either of those will be 4, 5, 6, which then removes 5 and 6 from that. So now we only have, the greatest we could have is 3 plus 2, which is 5. So these can't be 6 anymore, which would then place the 6 there. Okay, maybe we found what we needed. So that is going to be 6, and then, so 6 is not yellow. This is 6, right? Or are we not? Okay, let's just clean the other 6s up here. That's not a 6, and then for that one, okay. So 4, 5, 4, 5. If it's a 4, then we have 1, 3. If we have 5, we can't have 1, 4. So this is not 1 anymore, because, okay, it could be a 1 because of the 1 plus 3. But for the 5, it's not going to be 1 plus 4 anymore, and we don't have a 1 there either. And then we could still have the 2, 3. So 3 is actually guaranteed now of going in that column. So that would remove the 3 from there. 1, 3, and we said 1, 4 is now impossible, so it's 2, 3. Yeah, 3 is guaranteed to go there. Okay. So then this would need the 6. Yeah, that's right. Because 4 plus 5, that's only 9. And then 1, 2, 3, 4 is going to be 10 already. Yeah, this is the 6. Okay. That's going to be 6. We said one of these 6s would be there. Then either of those will be 6, and then either of these will be 6. Okay, that's not a 6. So 6 is there, which would place the 6 there, removing this 6 there. Let's see, 4, 5, it could be, so for 4 it could be 1, 3, and then for 5 it could be 1, 4, 2, 3. Okay, 4, 5, we actually have the 4, 5 pair there. So let's say this is going to be the red 4, 5. This one would be the yellow or red 4, 5. Not sure yet. Um, 6. Okay, to get to 7, we can only do 1 to 4, right? Because 1, 3, then we would go 1, 3, 3. I think for 7 that it's only 1, 2, 4. So we have the 1, 2, 4 triple there, which would give us the 5 there, which means 1, 4 or 2, 3. But this is now 4, which would make that a 4. So those will not be 4. And then we need 1 plus 3. This is the only one that could still be a 1. Why is that not a 1? Let's quickly think about that. What did I say that's not a 1? Let's just remove the 4 there. Why is that not a 1 anymore? I can't remember. Sorry, not that one. I'm not sure why I said that that's not a 1 anymore. Okay, but we are going to have 1, 3, which would remove the 2 from there. And then, let's see here, it's looking good so far. Okay. And then 2 is now guaranteed of going there, and the 4, which would remove 2 from there. So 1, 3, 1, 3, something is wrong here. Okay, actually, this is the 1, 3, 5 triple. And then these would be, so it's going to be a 5, and then 1, 2, 3, which would get us the 11. So this is going to be 6 plus 5, which means it's red. Okay, 6 plus 5, which means this is now yellow, which is the 4. So we are going to do the yellow there. It's going to be 4, and then this one is the red 5. Okay, That is not 5 anymore, which would give us the 5 there. That is not a 5. That would place the 5 there. Okay, let me just do that. So once again, this is also will also be the 1, 2, 3, 5, which equals 11. Let's just remove that. Let's see. 1, 3, 1, 3, 1, 3. And then the 1, 2 there. 5 and 6. 1, 2, 4, 1, 2, 4, 1, 2, 4. Okay, this is the problem here. If we place a 1 there, we can't do the 1 there. So this is gonna have to be a 2 now, which would then remove 2 from going there and going there. So then this is a 3, 6 pair. So then that one can't be 3, that can't be 3. So then let's see, it's gonna be, we can't do the 3, 2 anymore. Yeah. So this is not a 2, this is gonna be a 1, making that our 4. And then that will be the 2, 1, 2, 3, which would place the 3 there, placing the 1, placing the 2, that's going to go 1, that will be 3, that will be 1, and then we need 2 and 3 here, so that's going to be the 1, which would place the 4 and the 1, placing the 2 and the 4, let's see, what could we do with this? Should I quickly clean up these? Okay, let's see what we could do. Let's clean up all of these. 1 and the 1 and the 1. Are we still good? Yeah, okay. So this is going to be a 2, 3 here, and that's a 2, 3, 3, 5, 2, 3, 5. What am I missing though? 3, 6, 3, 6. These are 5, 6 definitely. Oh, it's the 4, the sandwich. So this will be the 6. Okay, now we should be good to go. 3, that is going to go 2, making that the 5, making that 3. That's 5, that's 6. That will be our 2, and that's 3. There we go. Perfect. 21 minutes. Okay, make it 22. Anyway, that was quite a fun solve. I like the challenge of like thinking about the region sum lines, and then this sandwich 4 here, which solved the puzzle in the end. We couldn't have done it by Sudoku or something like that. Okay, we needed the sandwich clue up there for the 1, 4, 6, and then we managed to quickly solve it. Okay, cool. That's it for this one then. Thank you for watching, and goodbye for now.